Hi, my name is Will Chung, and I'm a data scientist. In the previous two videos, we explored what LLMs are and also how to evaluate the answers that come from them. Today, we're going to look a little bit into the architecture behind LLM chatbots because LLMs is the engine that powers these things, but there's a lot of design choices around the LLM in order to make the chatbot go. And so if we look at a high level overview, there are essentially four different layers that conversations go through in a chatbot. If we start with the first one, we have input processing. That kind of takes in the question that you ask the chatbot, as well as all the external context, like previous conversations or previous questions you've asked. Then that flows into the RAG retrieval, which is a document retrieval process in order to fetch the right information to answer that question. And then we have the LLM inference, which takes all that information and decides how to compose the answer. And last but not least is output processing, which then takes that final answer and just essentially makes sure that it is in the right format for the end user. Now, we've kind of walked through these four steps in order, but in reality, sometimes we might skip a step like RAG if we don't need any kind of internal information, as well as iterate between steps in order to refine the answer for you before giving it to the end user. And that's all built on top of a lot of engineering infrastructure that we'll also kind of briefly look at the very end. So in the first step, when you have input processing, a lot of times people just very casually type things into a chatbot, right? People don't really proofread as they kind of converse through these LLMs. And a lot of times there's a lot of cleanup work that needs to be done. And that's essentially message normalization, right? You have to trim all the extra spaces people put. You have to spell check and make sure that you correct the spelling of certain things, as well as for security reasons, strip out any personal information that people might input and kind of encode that in a way where maybe you're not risking the privacy of the end user, right? And then in the next step, we have safety and moderation, which kind of evaluates the question itself. Is it like a question that is asking for something that's rather dangerous, right? Like how to build a particular weapon, and or you're asking the LLM to solve a math problem that is going to burn all the resources, right? So these are the things that they're going to check before even attempting to answer in order to prevent certain safety or resource considerations. And then the third step, we have intent detection, right? This is trying to make sure we know which of the who, where, when, how kind of questions are coming in, and so that we can, or the chatbot can better answer your question or know the scope of where your question is going. And then in the fourth step, as we kind of mentioned before, you might have a history with this chatbot, and there might be other contexts or cookies that it might have tracked. And so it will also compile that information in order to better process what you're trying to ask. For example, when people ask, what is the weather? What they really mean is, what is the weather today? But that context is kind of derived in the input processing. And so in the fifth step, we have query rewriting, and that's taking all the information we've retrieved in that step 4 and trying to enrich the question being asked in order to make it a more clear question, right? So in that example I just gave, when you're asking what's the weather, it might rewrite it to what is the weather today or even now, in order to kind of better shape the question for the next few layers later. And last but not least is routing. And so a particular chatbot might have access to a lot of different tooling. And so a lot of times it has to make a decision in terms of thinking, okay, is this like something an internal document has or an external server that I need to go and fetch? And so that kind of decision is also being flagged in the input processing step. And now in the next layer, we have the RAG layer, or retrieval augmented generation layer. And so how to think of it is that it is just a very organized way to fetch the relevant documents to your particular question. And a lot of times when we're saying relevant document, these are essentially in-house or private information that's not readily scraped on the web. Because a lot of these LLMs are trained on web data, but a lot of these chatbots might be kind of more unique or specific to a certain area. A good example is like, let's just say you are trying to ask an internal in-office chatbot about an office policy. Well, your office policies for your company is not available to the public. So the LLM, most out-of-the-box LLMs are not trained on that data, but through RAG, it can retrieve maybe the right HR document in order to answer your question, right? So it's like a more private set of data that it can kind of go through and realize what to retrieve. And so you might hear RAG a lot when you're learning about AI. And so it's more in terms of like organizing private, non-public information for your AI to then retrieve. So how it works is that essentially now you have your question from your input layer. It then tries to translate that question into a particular document that could be hypothetically the answer to your question and try to find that within the space, right? That's the query transform. And then there is a way to kind of search through your local library of information to fetch the right documents. And then last but not least, once you fetch these right documents, you need to kind of rank them in a way to say which one's the most relevant and which one is the least relevant and which ones are not even relevant. And so you'll have a ranking algorithm as well. And those are the three different pieces of the RAG workflow. And so an easier way to think of it is it's very similar to Google search. And so in Google search, you have like a big library of all the different web links in an inverted index. And you'll have something very similar in a RAG pipeline where you have your local library and it is kind of organized in a certain fashion so that you can fetch it relatively quickly, right? Then you have a kind of scoring mechanism in order to calculate how relevant things are, right? You have the BM25 keyword scoring for Google, and you'll have some kind of scoring mechanism for your RAG pipeline as well. And then that way you can kind of figure out, hey, what is relevant? What are the documents that are relevant to the question I want to ask? And then, like we said before, there's a ranking mechanism, right? Google search ranking is like a very thought about topic because people want to appear top of the list when you have a Google search. But in the RAG pipeline, we also are considering how to rank certain documents in order to kind of figure out, okay, these are the relevant ones, but which one are the most relevant to our particular question. And last but not least, Google returns this entire list of links that you can click into and read on your own. But with our chatbot, what it does is kind of synthesize these answers from maybe a select few of those top ranked references and tries to produce an answer with those information. All right. So now to look at the differences between how these RAG system works and Google search is that Google search is like a one-shot thing. So you kind of ask it a question and then it'll give you an answer. But if you ask it another question, it just starts fresh, right? So it's kind of stateless. It doesn't try to retain all your previous searches and impact how your search is in theory. And so in an LLM, you might have a multi-turn conversation, right? And essentially each turn is like a um, instance where you go back and forth with the chatbot. Right now, we might have a long conversation, so we might have a lot of turns, and those things are kind of kept as context for your future question, right? So as you ask it things, it will remember what you asked before and impact how it'll answer it to you. Um, so a lot of times all these search engines don't have a reasoning component, although they've kind of recently added that through LLMs. But reasoning is one of the core components of a chatbot where it kind of not only returns the references, but answers your questions based off the information from those references, right? Um, in a web search, they only have public information, right? Because that's what they're doing, and they're crawling through the web to kind of give you the relevant links. But once you interact with the LLM chatbot, a lot of times it also has like trained knowledge and also in-house information retrieved from the RAG systems um, in order to better answer your very specific questions. Um, and then a lot of times for the search algorithms, it's only a read-only thing, right? They send you links, you can click on it and do things on your own. But LLMs can also do a multitude of things, not just return you some answer, but actually maybe even execute a command on your behalf. And then last but not least, when you enter something and the search algorithm gives you a bad result, what that usually means is that you kind of get a list of irrelevant links. But when things fail in the LLM chatbot world, it either gives you a wrong answer, or in a more dangerous situation, it can kind of execute a command that you didn't intend to. So that's why there's also a lot of guardrails to prevent things like that um, in a chatbot system. All right. So in the third layer, we have our LLM inference, right? And so, you know, in the previous two layers, you might have thought, wait, does that not involve LLMs? And the answer is actually all the layers involve LLMs. But in the first two layers, a lot of times they're using more cheaper models, smaller models, in order to answer those kind of prep questions in a cheaper and faster way. And you would normally use your heavy, expensive model in this third layer to kind of compose the answer, right? And so a lot of times it receives all the information from the input layer. That's the context window, right? You have all the different chat history things, even examples of previous questions asked in a different context, maybe, in order to kind of show a better format. All those things are ingested, kind of somewhat discussed in our first video. And then there's also a lot of configuration going on based on the question and design of the chatbot. You might structure the LLM behavior in a certain way with system prompts. And last but not least, it's just a lot of different things it can do, like chain of thought, which is kind of more iterative reasoning, where it does a little bit of work, it breaks down the work into little pieces, and then kind of loops through those pieces in order to make sure everything's right. And so this is where the big heavy model does its work in order to produce the answer, right? So the first two steps is setting up the things needed for the answer. And then this third layer is kind of helping combine all those things and produce an answer. And that's why we use the kind of most expensive LLM in this third layer. And that's the key difference between search algorithms and chatbot is like search algorithm um, might do a lot of things similarly in the first two steps, but in LLM chatbots, this third inference layer is kind of the doing a lot of heavy lifting, and the search algorithms generally don't employ this until maybe recently they have some kind of AI summaries. But this is where the heavy lifting is being done and the reasoning. So a lot of times that can involve like follow up questions because it might realize that hey, there's a lot of ambiguity here. Um, Even when you ask like, "What's the weather?" I couldn't get your GPS information, so maybe I will go back and ask you like, "Hey, well, where are you located?" in order to get the right information, and all those kind of things that a normal search algorithm can't do. And last but not least is the fourth layer, the output processing. And we mentioned a couple of these things before, but we do need a lot of guardrails because, well, you know LLMs are a lot more powerful than a simple search algorithm, and things can go wrong. So to protect against that, there's guardrails where okay, maybe I don't allow for access into a certain thing, or you cannot delete other things, and so these are protections so that people don't accidentally destroy things as they're asking questions about something completely unrelated. A lot of the structuring is being done in output processing. If it's a particular chatbot that generates JSON, then in this fourth layer, that's what it does is to make sure that it is structured in that way. Maybe even try to do certain things to maybe open the JSON just to make sure that it's structured right and doesn't throw an error, right? There's sort of those kind of structuring testing that it can do before giving it back to the user. There's certain things like some people might ask, hey, to the chatbot, I asked you a question, and at the very end, please provide sources, right? This is very common practice. And so when it sees those kind of things, it will also try to ensure that the sourcing is there. And last but not least, there is like tool calling. So in the very first layer, we kind of briefly brushed upon the fact that, hey, you might need information from another server. And so if that happens, right, in the output processing, we know, hey, we're not ready to return it, the answer to the user yet. We need to actually go fetch information that doesn't exist in the RAG, but maybe in an entirely different server, right? And so it might do something like that and loop through a couple more different steps in order to get the right answer before providing it to the end user. And last but not least, just little formatting things because sometimes AI, when they're thinking, it's not like in the perfect English language. And so it might have to kind of reformat its own kind of thinking and grammar in order to get it in a way that the end user can appreciate. Okay, so we kind of walked through those four layers in detail. And so let's go through a couple examples on how this kind of works, right? And so in our first question, what is the weather in Tokyo? It'll go through the input processing. It'll understand you're asking a weather thing. So it might be a call to a weather app because in the RAG database, you won't have like live weather information usually. And so it'll understand to kind of skip that. And so it'll kind of process, skip the RAG retrieval, and in the LLM inference, and understand, okay, we need to retrieve certain information before I can answer this. So in the output processing, it will call maybe some kind of weather app or something, and it'll get the weather for Tokyo at the moment, and then send it back to the LLM inference step. Once it has that, it might compile information to you. It might even make some recommendation if it's raining right now. Don't forget an umbrella. It might add a couple of things like that in the inference. and then flow back out into output processing, and package it and send it to the user. All right. So that's kind of one example. Another example is if someone talks to an internal company chatbot and say, "Hey, what is my company's process for requesting a new office equipment?" Right? You're a new employee and maybe you want to uh, get a new monitor or something like that, and so you can ask that in the internal chatbot, and so it will go through input processing. It might have context that you're a new employee and all those kind of things. And so with that information, it realizes, hey, this is internal information. So when it goes into the RAG system, it's like, okay, you have context as a new employee asking for new office equipment. It will be routed to the right documents to kind of fetch you that answer. And so after that, the LLM inference packages it, maybe even sends you or includes the link to the original document that talks about the company's process for requesting new equipment, and then sends it back to the user after output processing. So that would be another workflow for an internal app as well. And we've kind of brushed over it a bit, but there's a lot of things being built on the infrastructure side in order to make this all happen, right? And I'm a data scientist, so a lot of times I build a lot of things, but some of the heavy lifting like this is done by engineers. But if you're in a more smaller size company, you might have to do all these things on your own, right? And these things essentially include saving things, right? A session state, which kind of essentially defines what an interaction looks like, right? You have a entire conversation. You might close the application and then save these things into some kind of database to retrieve later. And you have to define these kind of things, right? You have to cache certain things that maybe you've asked a question 10 times before. And instead of running through this whole process to answer your question for the 11th time, it realizes you asked this question very often. And so it'll just fetch that answer for you without having to use too much resources, and a lot of different things about like vector DBs, because you have to set up your library of local information in a certain way so that RAG system can run properly. And last but not least is the eval pipeline, right? We talked about evaluation in the second video, and you have to build that in throughout the different 4 layers in order to ensure that things are going well and things are graded in a way that makes sure that the answers are reliable at every step. And that is a very brief overview of the architecture design of a general chatbot powered by an LLM. Thank you. Like or subscribe if you want to see more videos like this. Bye.